Good afternoon to all of you. Hope you are enjoying the sessions on the LaTeX. So I welcome all of you for this session on the technical writing using LaTeX. So for the today's session, we have Dr. Neha Gupta. Madam is B and from Electronics and Communication Engineering from Rajiv Gandhi Pradyogiki Vishwavidyalaya Bhopal in year 2021. And she has done her master's in communication system from Jabalpur Engineering College 2014, and she has done her PhD from NIT Rourkela in signal processing 2019, and her area of research is satellite image processing, multi-resolution satellite image processing, machine learning, and deep learning. And today, madam will be talking about how to write mathematical equations that we feel very much difficult in writing the other processors. So, madam will be discussing about that. And meanwhile, I will request and suggest all of you to keep practicing all the sessions parallelly so that you can have experience of learning. And any doubt you are having, you can ask it anytime from this session or previous sessions. You can ask to any of our experts in any of the sessions. So I welcome, madam.
Thank you so much.
Over to you.
Okay. Sir, is it visible clearly?
Yes, ma'am.
Okay, so good afternoon to all. So today's session, as already sir discussed, is about the mathematical environment. So first I'll give the demonstration on the PPT, like what we are going to cover, and parallelly we will see the demonstration in overlay also. Okay, so here these are the outline of today's session. First, we will see which packages we have to install when we want to work in the mathematical environment. Then after that, we'll see one by one which type of mathematical notations we are going to use into the research article or any type of paper writing you are doing. So either we are writing equations or we are writing those mathematical notations inside the text, or separately we want to write anything. So all these things we'll discuss under this point. After that, we'll start the typesetting of the equation. Few examples I'm going to show you, and basic example. Then after that, we will see the advanced equations. So in that, we'll see the matrix notation, how we can represent the matrix, matrices, how we can write. Then in advanced equation, we'll see the multi-line equations, equation array. If we have the like any complex equation like binomial or fractional kind of thing, if you have, we will all these things we are going to see in advanced equation. And the most important thing is the alignment. If you have the multi-line equation, so how it can be aligned, all those things we are going to see in advanced equations. Then after that, we will see the labeling and referencing, which is most important part of the research writing. Whenever you want to refer the equation, then how it can be written into the text, that we will cover under this point, labeling and referencing equations. Then we'll see the few basic things, font sizes, how we can change if you want to change in the equation, and mathematical symbols, like we have too many mathematical symbols. A few example I'll show you so that it can help you if you want to write anything, if you have your equation and you don't know how to write those symbols into the LaTeX. So this point is going to cover all those things. It will help you to get to know like how to write the symbol exactly in LaTeX. Then I'll show you at the end, without the help of knowing anything, like if you don't know about any packages, not packages, sorry, any symbols, how it can be written into the LaTeX, like cos, sine, tan. If you don't know how to write into the LaTeX, so we also have the writing tools like math type. Okay, in that we can write easily, and that can be copied and pasted into the overlay. It means it is going to directly give you the code of the equation. So that is also most important part of the today's presentation. So I'll show you that tool also, and at the end, the website from where we are covering the things, I'll show you that. So first of all, I'll start with the packages. These are the two main packages you have to take in your document. I think you all know how to create the document. I'll show you also into the overlay. So these two main packages we have to install when we are working into the mathematical environment. The first one is AMS Math. The second one is AMS Symbol. The first one is going to create the environment. Whatever type of equation you want to write, whatever type of symbols you want to take, all these things are going to cover inside this package. And if you want to write advanced equation, if you want to use symbols which are not included in this, so this package is going to be helpful. Okay, so it is just like the extended version of the symbols and the environment we can get with the help of this package. So both are very important package you have to install. So I'll show you into the overlay so that when parallelly you want to work, you will not get any error. So just see, from this, you can create a new file. Here you have the option. After creating any type of class, you can write here. Right now I have written article, document class. Then beyond that, I have taken here these two packages, which is going to be helpful for this mathematical environment. And one more I have taken, like I'll show you one more thing, color, if you want to change the symbol colors or any equation color you want to highlight. So for that purpose, one more package I have taken here, X color. This one you can also install. Then these are nothing, you know very well, title and author just I have taken. And then you have to write the begin document. And when you are beginning it, you should end also. So at the end, you should type end document also. I'll wait for a few minutes. If people just create the document like this, the way I have shown. And by default, like I have written one section introduction. This is available in on the article, in every article. So about this, you know very well. For this large, I have just written for the purpose, like you can see the output easily. To get the large size of this symbol and font, I just use this large. You can use this or not, it is not mandatory. I hope all of you have completed this. So after using these packages, now we will see which type of equation actually we are going to use in our text. Okay, so there are three types of representation. The first one is inline. If any expression you want to put like this, you see one example is mentioned here. Expression should be always written in dollar sign. If you want to put any symbol or any equation representation, any mathematical expression you want to keep inside the text, that is called inline representation. So inline representation means, suppose between this expression and should I want to give one variable. So in directly in place of writing, suppose that variable is a, I'll use the dollar symbol. So that is mentioned here. You see, I have written this mathematical expression inside $2. So whenever you want to write any symbol, any mathematical expression inside the equation, just take $2, and between those $2 sign, you have to put your mathematical expression. So when you will run this, you will get this type of output. Just see, this A is different what we are getting in this text because we have used the dollar sign. So your mathematical expression will come in like italic type of representation. You will get this. First inline expression, then we have the display style. Display style means it is again like inline expression you can use inside the inline expression, but which way you want, whether you want it just like the content you have, the size of this expression, like see here, not this, it is almost matching with the size of the content, or I want to make it different with respect to the text what I have here. So if you want to represent this in this form, like it should be full sized inline expression, then you should use display style. And for that, we have this command. I'll show you all these things in overleaf also. So for that, you can use this /display style. And then after that, whatever equation you have, just write, you'll get the output like this, the full sized inline expression, which is this expression is bigger than what content you have used here. And the third one is equation. For this, we have the separate environment. We'll write that environment first, and then it is always going to come in center of the page. Okay, whenever we are writing equation, it always used to come into the center of the page, but for that, you have to give the specific command. Okay, so all those things I'll show you into the overleaf now. Okay, the same thing I have written here. Expressions should be written between the dollar. Again, I'll take this. Okay. Anything you can write and then just use the dollar symbol like this. Now inside this, the simple basic thing you just write right now, A equal to B or A minus B. Anything you want to write, you can write A equal to B plus C. So see, we got the output A equal to B plus C. Since this is inside the dollar sign, so we are getting like this. If suppose this is not inside the dollar sign, so you just see the difference in which way we are getting the same thing. I'll keep the content without dollar. See the difference here. This is when we have written into the mathematical environment, and simply we have written. Just see the appearance of the symbol. It is different in both the cases. Sometimes we used to forget also when we are writing the research article. So if your content is not appearing into the italic way, the mathematical expression, so it means you forgot to write that inside the dollar sign. So inline expression, for that, this dollar symbol is important. So inside the inline, always use the dollar sign. Now I'll come to the display style. You can write any content and just try with the other symbols also what you have in your laptop, and later on I'll tell you the few symbols also. One more thing is written here, just see in this expression, the output is square root a square plus b square. So for square, to get the power, I have used this symbol here, a square plus b square. Exponent symbol I have used, a square plus b square. To get the square root, there's the command in LaTeX /sqrt. just type /sqrt. Automatically it is going to provide you the whole command, and then inside this curly braces always whatever content you have you should put. Okay, the way like here I have represented a square plus b square, it will come inside this curly braces. So we have seen how to write the inline expression. And one more thing here, the basic things I'll cover uh, slowly with the all type of expression. Power I have shown you, like how to get the a square, b square. If you want to get a cube, so directly you can write here 3. It will give you the a cube. And this left side, just see what I have written here, a underscore 1. So what it is going to give you, this is the output. Subscript, you will get a1 in the form of subscript. If you want to write anything, you can use the underscore. I can change it to 2. If I want to keep 2 variable, I'll use here curly braces and I'll write here 1 2. Suppose any variable is represented with 1 2, then inside the curly braces, whatever content you have, whole content you just put inside that, it will come in subscript of this a. So with the help of these two things, now you can write basic equation just for the practice purpose. Now I'll show you the different color first, then I'll come to the display style. Inside the inline expression, you have seen we have used the dollar sign to get the expression. Now, if you want to highlight any uh, symbol into the different color, okay, so we have the option of changing the color also. Like here you can see I have written so many things here, a plus b, a minus b, a multiplied b, a division b, here you can see. But for one thing only I have used here color violet. Okay, so for that you can use the command text color with the slash text, you will get it automatically. Okay, now here we have the two curly braces. Text color, the first curly braces, here you're having, in this you have to write which color you want to display in the text. It can be black, can be red, it can be green, it can be blue. I'll show you the different color which is available into the overleaf environment. Okay, so the first curly braces should be used for the color designation, and then the second one, here you have to use your expression. You have to write your expression inside this. Just see the first one I have taken here. This is color. This color is different than other. If it is not visible clearly, I'll write here the red one. The A plus B. I can change the color red to green or blue. Okay, so we have so many colors. These are the list, and what name is there for the color, the same thing you will write there and you will get that color. Like I have written the violet, I have written the red. If you want green, blue, cyan, whatever you want, you just write the same color inside that first curly braces and you will get your text in that color. So these are the examples. If you have written, just try with the different color, type it olive or lime, whatever you want. suppose I want to use brown. You see, my A plus B is coming in this color. So sometimes in few article or even you are preparing your rebuttal, like submitting the revision, if you want to highlight anything, any equation, you can use this command text color, and in this way you can change your expression. Okay, so now I'll come to the display style. Okay, till now we have seen the inline expression. Along with that, I have covered the text color. Now we'll come to the display style. Okay, so here just see, for the display style, you have to use this command display style. First, write anything, whatever you have, the content. I want this. Then inside inline, if you want inline expression, again, you can use the dollar. And then I want to use display. So I'll write like this. Okay. After that, whatever equation I want to write, simply I can write A equal to B. See the output I am getting here. This I am using only for getting the extra space so that you can see the output clearly. There's no use of this inside the mathematical environment. Okay. So display style, without display style, you can see the difference. But with this, you may be not able to observe. The main thing here, just see in this expression, as I have used here with this summation, the display style sum here, summation of n equal to 1 to infinity 1 by n is written. So first you just see how to write 1 by n. Okay. So for that we have to use the command frac. Fractional thing is written, you just use the command frac. FRAC. Okay. You just see automatically option is coming. You just click in that. Two curly braces came. Inside the first, you have to write the numerator. Into the second, you have to write the denominator. Similarly, you just see 1 by n is written in my expression. Right side, see, this is my expression. 1 by n is written. So in numerator, the first curly braces I have written 1. In denominator, I have written n. And for this summer, for this sum sign, we have this command into the LaTeX /sum. Okay, so the way it is being used, already I have explained you the concept of underscore, and if you want to get any power, okay, both things I have explained about this symbol and about this. Since here we are using the same, like see here, n equal to 1 to infinity. So for getting this subscript, if I'll say this in the form of subscript, I'll use that underscore. This expression is not having single variable. We have n equal to 1. So whole thing is coming in the subscript. For that, here I have written that inside this curly braces. Whole thing is written inside the curly braces. If I won't use this, this is not going to be displayed like this. Okay, I'll show you what I want to say. I've taken the same thing here. Okay, if I am not using curly braces, so which way you will get the output here? Okay. In subscript, I want n equal to 1, but inside this only I have given this. Okay, so see here, this n is having size less than equal to 1. So whenever you have the big expression to keep in subscript or in superscript, you should use always curly braces. Okay. So for this, it is written with the sum subscript, then super subscript. After that, again, here we have the infinity. So for infinity, you have the symbol in LaTeX with slash infty. Okay, infinity it is going to represent the infinite symbol in your equation. So both thing I'll show you without display style and with display style. Same thing, you can see these are the two equations. The first one is with display style, we are getting the full size expression here, and without display style, it is coming like this. To get the I'll use some space here, then it will be clear. See the difference in these two. With the display style, it is represented like this, and here it is having the less size. So till now, inline expression and display style. Okay. Now I'll come to the equation editing. Typesetting the equations. First, I'll explain you here. Then again, we'll go for the practice purpose. So your mathematical expression can be written in two ways. The first one is using this bracket. Okay, with slash we have used the square bracket. It should be closed also. This is the first way to represent your mathematical content. If you want to create the mathematical environment, this is the first way. And the second way is using this command, begin equation. If you are beginning with anything, it should be ended also. So whenever you will type slash begin equation, automatically this end equation will come in overlay. Okay. So if you have not written, it will give you the error. So always first create the environment by using slash begin equation and equation. This is the second. Two type of ways are there to represent mathematical expression. The first one is with the help of this square bracket. The second one is with the help of these commands, begin equation and equation. In this square bracket, when you are keeping any mathematical expression, this is not going to give you the equation number. It will create the mathematical environment. You will get the equation easily, but it is not going to give you the numbering of the equation. You can see I have shown you here the output of this, and in this case you are getting the equation number. Okay, so sometimes it is required to represent mathematical equation without numbering, without any referencing if you don't want to refer that. So you can use this type of representation with the help of a square bracket. But if you want to refer any equation in your content, you should use this mathematical environment, begin equation and equation. So we'll see again into the overlay how to use these two commands there. See, here basic thing I have taken here, okay, y equal to x square plus 2. So first to create the mathematical environment, okay, if you want to create the mathematical environment, just take the slash and that square bracket. then it should be ended also. Okay? Whenever you are taking, automatically the next thing will come. Like how it is going to be closed, when you will type slash square, open the square bracket, automatically the second thing will come. Now between these two, you have to write your mathematical expression. Okay, the way here I have written y equal to x square, you can write anything. A equal to mc square if I want to write. Then I'll take that symbol square. Okay. Anything else if I want to write, you can see here the output is being displayed. If I want to change the expression, A equal to B, suppose, and I want to write the multiply. So for that we have the command times. Okay. So B into 2. If I want to get the division, suppose further in this equation, I'll write DIB 5. See, but this is coming without any number. Okay, the equation number is not being displayed since I have used this environment. I didn't use the equation, this begin equation and end equation command. So this is one way of representing. If at all you require, you just want to write the equation without numbering, you can use this environment. Okay, and if you want the equation with number, always use this command begin equation and AND equation. This is going to create the mathematical environment in your file at the place where you have mentioned, and then whatever expression you want to write, just keep between these two. Okay? So type begin. Okay? Even the option is coming, you just keep typing further because you want the equation environment. So at least till there you can type EQ. Now it came. Okay, 3 options we have. I want to get right now. Later on we'll come to that equation array. See, I have created the environment here. Now whatever I want to write, I'll write between these two. X power 5 plus x to the power 3 if I want to keep, and then plus, see, the equation first I'm getting y equal to x to the power 5 plus x cube, 2 times I've taken first. Okay, then x cube, then plus 2. So here again I got the equation number 1. Okay, now after that, when again you are using the same environment, so this is automatically going to give you the second equation. Like number is going to change one by one. You are using the expression, you are using this equation environment, automatically you will get the continuation in your number. Okay, like see 1 2 3, since I have used here 3 times that command, so from first, this first equation is coming, then second, then third. So the last one, which was displayed into the PPT, the expression was r of xy equal to x square. In like in fraction, it was mentioned x square. In denominator, we had x cube plus 2 to the power a. Then here one more symbol we have plus then b. Okay, so here like you can learn again, for the power I have used this symbol, and to write the whole expression a plus b, I should use the curly braces. Inside the curly braces, whole content should be written. Okay, and the frac command you know now. For the numerator, the first curly braces should be used. For the denominator, second curly braces should be used. Here x square is kept into the first curly braces and remaining have been kept into the denominator. The second curly braces we are using for the denominator. So I hope you people are practicing parallelly. Till now, we have seen how to create the mathematical environment into the any article. So 3 types of things we have seen: inline expression, then display style. If you want to get the full size expression in your content, for that you can use the display style. And the last one is equation writing or equation editing. So for that, I have shown you 2 ways to represent. The first one is this with the help of a square bracket. That is not going to give you any equation numbering if you want. And then the second way is this begin equation and AND equation command, which will give you the numbered equation. Can I move further, sir? Is there anyone? Students are comfortable with the practice till now?
Any doubt from any student?
Okay. Okay, so now we'll move for the advanced equation. First, we will see the matrices. Okay, so here just see 2 type of matrix are presented here. The first one representation where we are having the vertical lines. The second one where we are having the square bracket. So if you want to get this way of representation, for that separate command is there. If you want to get this type of representation, for this separate command is there. Okay, both are coming inside the matrix representation, but since we have the different representation, for that you are just changing the first letter here. Okay, just see here, to get the vertical lines you are using V, then matrix. Just type in your overlay / begin V matrix. You should end also. And to create the mathematical environment, either you can use this or you can use the equation environment also. Here just see, to get the bracket here, we have written B and then same matrix is written. So to get the square bracket, you should use this one. Now I'll go to the overlay and with there I'll show you how to get the number of rows and number of columns. See, first I have created the environment. Again, I'll take that. Okay. Square bracket. Now, since I want to get the matrix with vertical lines, so I'll write the command begin. I got the environment. Now, inside this, what is the requirement? If I want to represent only 1 cross 1 matrix, so I'll put only one number here. Okay, and in the output we'll get this matrix. See, 1 cross 1. Now, if I want to get 1 row, 2 column, so to get the column, we have to use this n% symbol. Okay, 1 n% 2. We'll see into the output what we are getting. See, 1 row, 2 columns. So basically, to change the number of columns, you have to use the n% sign here to change the column. And if you want to change the row, then you have to use this one. Okay, this is in LaTeX, this is being used to change the line. Okay, like whatever you want to write, it will start from the next row. So here again, I can write 2 n% 3. So I'll get 2 cross 2 matrix. Similarly, you can get more columns if you want. n% 5. So this is 2 cross 3 matrix. So if you want to get number of columns, suppose 5, 4 number of n% symbols you should use. If you want to get 3 rows, so one more time you can take this double slash, okay, and you will get one more row. So using V matrix, we'll get vertical line. Similarly, if you want to get the square bracket, then you have to use the B matrix command. It is written here. Just type, first create the mathematical environment by taking square bracket. Then type the begin B matrix. Okay, with the end command it came already. And if I want to take 1 cross 2 matrix, I'll use 1 n% to get the one more column, and see I'm getting 1 3. So in this way you can represent matrix either in the form of vertical lines or in the form of bracket, square bracket. The main thing here you have to understand the command which is being used for the matrix, which is B matrix and V matrix. Along with that, how to change the columns, how to change the number of rows. Okay, so double slash is going to help you to get the second row, third row, whatever number of rows you want. And this n% is going to help you to get the columns. So after matrix, we have the advanced equation. In that we are actually going to see the alignment and the way we can represent single big equation into multi-line, or you have the like if sometimes you want to simplify the expression. The first line you have, it is having the complex expression, then you are simplifying it till the end, but all the steps you want to represent in your article. So for that we have the option of multi-line equations. Okay, so here you can see the first one, we can use here equation array. Okay, array type of equation environment you can create with the help of this command, which is actually going to give you the multi-line equations. So here just see, we have this expression, mathematical expression fx equal to x to the power 6 plus x to the power 4 plus x cube. Okay, and then it is represented by this line, then again it is represented by this line. Randomly I have written anything, just don't bother about that. Just see like what I want to show here. If you have this multi-line expression, how you can represent it into the LaTeX. Okay, so main thing you have to see here, equal sign is coming with the alignment. Okay, if this equal sign is there, then below to that exactly again one more equal, then here, like means right side expression is starting at the same place in all the lines. So for that, what we are actually going to use inside the equation, that you have to learn, and how we are writing whole equations here with one number, that you have to learn here. Along with that, we are writing here multi-lines. So how it is going to be supported by LaTeX, that command you have to learn. So for that, in place of taking equation, we are going to use this command EQN array. Okay? This is going to create such type of environment where we can write multi-line equations. After writing this command, once you have created the environment, now you can start writing your one by one, whatever number of lines you have, all the equation. The first expression, just see here, fx equal to x power 6 is written. So in place of only having fx equal to x power 6 plus this, one more thing is represented here, that is n%. And it is being used left side of equal sign and right side of the equal sign. Then again, here we have the equal sign and second line expression is written. So left side we have the n%, right side we have the n%. Similarly into the third. So basically this n%, what we are using left side and right side of the equal sign, at which place actually we need the alignment. This is going to help us. 2 n% left side and right side of the equal sign will help you to get this alignment here. Okay, so you can see here n% at all the places is written. Okay, so we are getting this alignment. After this, one more thing is represented here, slash no number. This you know why it is being used. Already we got to know in last equation. To change the row in matrix, we were using this. If you want to change the row, so you can use this symbol. But why it is written slash no number? Okay. If you are going to use the equation array command, and if I'm not using this no number command, so what will happen? You will get numbering for all the equations, whatever you have in this expression. Okay, like you have 3 lines, for all 3 lines you will get the numbers, but I want number only for the last one. For the final expression, I want to represent this as my equation number 3. So what I'll do, I'll keep here this slash no number command. So it is going to remove numbering of that equation. Then further, I don't want to get here also, I have used the command slash no number. So for these two, I'm not getting any number. And at the end, since I have not used slash no number, so here I'll get the numbering of the equation, which is mentioned here, third. Okay, so we'll see this first into the LaTeX. Okay. Here we have the equation array. Just see what I have shown you there. So one more time, I'll type the same thing here. Begin, then inside the curly braces, E, Q, and equation array we want to get. First we have created the environment. Now I want to represent f of x. I want to get equal sign. Okay, and then suppose only x square plus 2. We'll see just by this what we are getting here. I've written this, I got, okay, x square plus 2. Now, if same thing I'm writing one more time without taking the help of n% and all, we'll see what we are getting into the output without writing no number and all. Just see what I'm getting here. I didn't change the line. So the expression is coming into the same line. First, to get the second line, I should use this. Okay, so I'll get the second row in my equation array. This I got. Okay, and to get the alignment, automatically it is coming right now. But if you have the multi-line equation, you should use n% here. It should be used here also. Okay. And this way you'll get the alignment of the equation. But since I have not used any no number, okay, so we are getting numbering for both the rows. I don't want to get it for the first one, so I should use here command no number. Okay, so this is the equation array. If multi-line equation you want to use, you can use this command. One more is there for the multi-line. If you have only one line equation or single expression, but it is big. Okay, sometimes you have the article which is having two columns. So with the uh, uh, in two columns, like if your expression is big, you can't write it into a single page. It will extend beyond the first column. So for that purpose, we have the splitting of the equations. For that, we can use the command multi-line. Okay, so place in place of equation array, now we are writing here multi-line, which is written as multi-line. Okay, multi-line actually it is written for multi-line equation. So first create the environment by using this expression. Then after that, just simply write anything with the big expression a plus b or a into b into c, anything simple, and just type this changing line operator, okay, double slash, and you will get this type of equation. Just see, I have not used any alignment and all equation array command, so I am getting this type of expression. It is shifted towards right side. This, then this, then this, and this is actually single expression. So for that, I am getting one number which is 2. Okay, so this multi-line expression will give you the equation numbering. Since this is the single expression, we are getting only for that this equation number is 2. So in this way, you have to learn only this multi-line command, and along with that, this double slash to chain the rows. Where you want to chain, that is your choice. Okay, if suppose this whole first line expression is not coming in your first column, so you can break it from the G also. Yeah, wherever you want to break, just you have to put this double slash, next expression will come into the second row, then again into the third row. At anywhere you can break it. How much you want to present in one line, two line, that is your choice. Okay, so multi-line is going to help you to get the single expression into the multiple lines. With equation array, you are going to get the same expression if it is being elaborated, or if you are getting the simple expression, this type of equation writing if you have. So it is going to help you to get the alignment here. Okay, for that you can use n%. Without using that also, you will get the alignment. Okay, like this also, you can use equation array and multi-line. One more way of representing the like if you have multi-line equation is gather, using the gather command. Okay, so with this, we are going to write whatever number of expression you have. And again, for changing the line, you are using this double slash and just create the environment with begin, gather. Here, this symbol is written, okay, as this sign here also. Without this, you just see what is happening in your equation. And with C, what type of output you are getting, just check the difference also. So here it is written a square plus b square plus 2ab. Okay, so and here a square plus b square minus 2ab. Since I have used here this double slash, I am getting it into the second line, but I am not getting the equation number. Okay, when you are using this gather with this sign, you are not getting the equation number here. So just see if you are using that sign or not using, which type of output you are getting in your overlay. I'll show you into the overlay. First, for the multi-line, you just see. For this is the output. I have written one expression, multiplying this. I have entered this double slash after k. So with k, I am getting here the second expression, the second line. But if I want to get below to this, that expression, you can use h space. Okay, just like if you want to get that expression just below to that, if you have like expression is large, you don't want to uh, uh, you want to utilize that space also, you don't want to waste that space, so you can use this h space also. Otherwise it is not required. Okay, directly you can also write. I'm just telling the way you can utilize the space if you want. If you want to shift this up to this place, just write that h space with the minus sign. Okay, I can decrease it with 3.5. So I'll get this expression from here like this. The third one, if you want to get from here, again you can write this h space. Okay, so this is one more way of utilizing the space if you're having less space. So in this way, you can also design your equation. For the multi-line equation array I have shown you. Now I'll come to the gather. Okay, so with the help of gather, here it is mentioned x square plus 2. This is the output. X cube plus x square plus 2. In subscript 1 is written and 2. So for that we have used the underscore and 2. Okay, so see, it is coming into the center of the page and by grouping all the equations. And if I won't use this symbol, then what changes we are getting here? See, if you are not using that, it is going to provide you the equation number. For each and every line, we are getting here 8, 9, 10. Yeah, in equation numbering we are getting. So if I don't want to get the number for this set of equations, for this set of mathematical expression, I'll just use that asterisk sign here. Okay, if you are keeping one place, it should be ended also. Same thing should be written everywhere. Otherwise, it will give you the error. And I just gathered my equation like this way, for which I don't want to display the number. Okay, for that you can use this sign. This symbol you can get from the laptop and you just put that symbol, you will get without number this grouping of the equations. So any type of equation you can write. Okay, if again I want to use this double slash, then it will come into the same line. Okay, so using of this in multi-line equation is important to change the line. Along with that, whether you want to get the number or not, that is also important. Without this sign, okay, if you are using no number. Just see whatever you have done till now, practice with everything. It is working here or not. Okay, I have shown you the no number command in the equation array. Same thing can be used here also. If you are not using that as a symbol into the gather, so to get the equation without number, you can use here again no number command. Similarly, for the next case, if I don't want to get the number, since I have not used that symbol, again I can write here no number. So I'll get second one also without numbering. So for the case of multi-line equations, we have seen 3 to 4 types of command. The first one is equation array. The second one is multline, multiline. Okay, and the third one is for grouping and centering the equation. You can use the gather command. Okay, these 3 types of things you can use for the advanced equation typing, where you have the multi-line equations. Now one more we have here, case-based definition. Most of the times in articles we used to get this type of equation. Okay, cases where like if x is irrational, then what will be the output? If this is greater than or less than the threshold, then what should be the output? Always used to get that type of equation. So for that, what is important here, this type of environment you are going to get with the help of the cases in LaTeX, which is being called using begin cases. Okay, just see the command. First, inside in this, we have created the mathematical environment with this square bracket. Now I have the expression like fx equal to, then this side we have taken the curly braces. This is actually the cases representation in mathematical expression. I have two cases, x is irrational and x is rational. So if x is irrational, then output is 0 or the expression is 0. So to get this type of thing, we are going to use begin cases, and it should be ended also with the same command, cases. Okay, so you have to write these two. Then inside this, I should get 0 and 1. So for 0, this expression is there, x is irrational. So see how we have separated with the help of and percent. It is just like the matrix, we have used two columns. Okay, so here you have the two columns. The first one is representing 0, 1. Second one is representing x is irrational and x is rational. So that column actually we are changing with the help of the and percent. 0, x is irrational. 1, x is rational. But why we have not written that directly? Why we have used one more thing here, math rm? What is the use of this? Okay, so just see here, x is coming into the different representation. It is having the different representation, and this is written into the different way. Actually, if this is not symbol, this is the information or text. If you want to write, it should come into the similar representation what you have in your content. Okay, whatever text you have written, your sentences are written in which format. Inside the equation, this information should come into the similar format. Okay, so for that, you should change the mathematical environment for that particular text. What is written there is irrational. Okay, so to change that, always you have to use this command slash math rm. Okay, it is actually representing your content. If you want to use this, your whole content is being represented like you have written some mathematical expression. Okay, but that is not the case. It is the only information you want to provide for this particular x symbol. Okay, in the mathematical expression we have the 0, 1, x, x, but this is the information we are providing for this particular symbol. Okay, so For that, we should remove the mathematical environment. So how it can be removed? By using math RM. We are actually creating now the environment how this information should be represented inside the cases. Okay. So at the both places, we have used math RM. You just type this without math RM, what you are getting, with math RM, what you are getting. Just notice the difference in these two. See, here, if I am not using this math RM, then what I'll get? This is my output, and this is the with math RM. See, is irrational. It is coming just like the symbol representation is there in italic form, but that is the not correct way to represent the content in your equation. Okay, so always you have to use this math RM command if you are writing the information inside the case or what type of equation you have. Sometimes it is required in other type of equation also. Okay, so in that case, you can use math RM. So here you have to actually learn about the cases. This type of thing, if you want to represent, then you should use cases command. Okay, and between that, how many lines you have, you can write change. If I want to increase the line here, suppose one more cases I want to keep here, the same thing I'll represent one more time by changing the row. Sometimes you have three cases, suppose 0, 1.5 value if I have. Okay, so in this way you can change it. One more row I have changed. Here I can use 0.5 suppose. Okay, and the same thing I'm getting here with one more row. So to change the row, always we are using this double slash. We are changing the line. Okay, and to get the columns, since here two columns, again we have used here n%. This is just like the matrix we have seen. By changing the row, we are changing with the double slash, and to get the column we have used n%. The main thing to get this left side representation of the process, which is actually the representation of the cases, you should use begin cases and cases environment. Okay, since here we have not used any mathematical environment with the help of begin equation, we are not getting any equation and all. Okay, since I have used here square bracket and ended with that, so I'm getting without any equation number this expression. So in this, you can learn about the math RM, what is the use of that, and the n%. So inside the advanced equation, one more thing is there, binomial fractions. Already I have shown you. Okay, one more time you can see for the fraction what command we are using. And in case of the binomial, we know like how it is represented. You can see into the expression binomial, we have this type of representation. So how can we get it into the LaTeX and that same thing is coming into the output? For that, we have the command. Okay, in LaTeX for every type of mathematics. If you want to write like logical expression, if you want to get the symbols like you have in logic gates. Okay, the way we used to inside the circle cross is there, inside the circle dot is there. For all these type of things, we have the different command, we have the different symbols, which is written always with the help of what like name is binomial, so it is written as binom. It is simple to remember also. If you have used it 1 to 2 times, it will always come into the mind. And if you know the initial words of those things, it just start typing with this last, automatically the expression will come in overleaf, and just click on that, you will get the whole expression. And also you will get like curly braces 2 or 3. So in that way you can write the expression easily. Okay, so for the case of binomial, we have this binom command slash binom. Okay, so here it is represented with two symbols nk. So two curly braces came. Just type the binom in your overleaf. You will get two curly braces. The first one, this n should be represented and this k should be represented. And the left side expression, we have only fraction type of thing. So numerator, denominator already you have seen. For the numerator, first curly braces here n with that symbol is written. Okay. So this side only the fraction thing. Right side you have to learn the binomial. Like this way it can be represented. So till now we have seen in advanced equations the matrix representation in vertical lines and in square bracket. Then in multi-line equation, three ways I have shown you with the help of equation array. Here automatically you'll get the like alignment, or you can use the n%. In this case, multi-line single expression you want to represent in multi-line. If it is big, then you can use the double slash and multi-line environment. If you want to remove space, you can use as a space command. And the third way of representing the multi-line equation with the help of this gather command, where you can use this symbol of asterisk. Okay, if it is not written, your equation numbering will come. That can be removed by using slash no number. If you want number for all the equations, then no need of writing anything. Okay, if you don't want number at all for all the equations, write the way it is represented here. Okay, so three ways I have shown you in multi-line. And the last one, we have seen the case-based definitions. For that, you have to mainly learn this type of content always in case we used to write. So that always should be represented with math rm, and cases you have to use. And the last one is binomial. One example is given for the advanced equation. For that, like this type of commands are available into the LaTeX. Now coming to the labeling of and referencing of the equation. Okay, we have written the equation, but inside the text, if you want to refer that, okay, like figure you are representing with the command is there, like this is shown in figure 4. Similarly, equation 5 represents this. If you want to discuss about equation 5, it is represented in equation 5. Okay, it is shown in equation 5. So how it can be written into the LaTeX? For that, we are going to use first the label command. Okay, you just see one simple equation is written equal to mc square. So for that, we have written begin equation and equation. This will automatically going to give you the equation number. The way here it is written 1, it came. Okay. Now, if I want to refer this inside the text, like it is written, the equation 1 states mass equivalence relationship. So how to get this referencing? For that, this command is important. EQREF slash REF command is also there. For equation, you have to write EQREF. Okay, so it is going to give you the referencing of the equation, whatever number of equations you have used. First, always label all those equations, and which one you want to refer in that text, that label should be written inside this curly braces. Okay, for example, here I have written for this equation 1. So the same thing I have written inside this curly braces EQN1. Since this equation is having number 1, so in the text I am getting the equation 1 states mass equivalence relationship. Okay, so this is called labeling. Labeling can be done here also. You can write labeling just after this begin equation also. Okay, that is also the same thing. It will give you whatever it is written here. Okay, like at the board, it by ending your content inside the equation environment, you can write, or just write after beginning this begin equation command, you can write your label. Okay, so this is important part of the mathematical environment. Always we have to refer the equation in our content. So you just see into the overleaf how we are going to do the labeling. Okay, you just see the same expression I have written here. Begin equation and equation equal to mc square. Label is written equation 2. Okay, so see in the content, the equation 10 states mass equivalence relationship. If I'll write this here, are we going to get any difference? We'll see into the output. Is it changing anything? No. Okay. So at both the places you can write. If I have multi-line expression, suppose one more time I have the same expression. So I should use this at the end if here I am using. Okay, like this. Okay, here the environment I have not taken multi-line, so it is not coming, it's fine. So mainly you have to learn about the where you should put the label. Once I'll take the environment for multi-line. See, now the same equation here it is written with 10 and 11. And 11 and 12. Okay, two expressions since I have 11 and 12. I have represented here with label here. Okay, so it is coming by referring that number 12, the updated one. If I'll keep this label here, then what changes we'll get, we'll see. Now it is referring which equation? The first one. When I have used here, then first one is being referred. So in case of the multi-line, which one you want to use? Besides that, you can write. Okay. In case of the single line equation, it will work here or there, anywhere. So the main use of label is you should write the name of equation if same uh, if you are going to give the same label to all equations, so when you are referring, the last one is being referred into the content. So always try to change the labeling of the equation so that anywhere if you want to use, you can use it easily. Okay, so it label can be written just right after the equation or at the end of the expression, or if you have the equation array, so in that case which one you want to discuss, there you can write. In this way you can also use this label command. Okay, so in this way you can refer your equation into the content. So up to here, I have shown you how to write the mathematical expression with the help of different type of commands. The equation labeling I have shown you, referencing I have shown you. Now I'll show you the font sizes, like the basic thing and the different type of symbol for that, what commands we are using into the overlay. So I'll start with the font size first. You just see one expression is written here, integration of the expression f inverse 1 x minus xa then dx, and it is represented with the four sizes. Okay, you can see here bigger one, then we are reducing the size. So in the mathematical environment, how it can be reduced, how it can be represented, it will depend which style you have used here. Okay, the first one already I have shown you, display style. Okay, that already I have shown you. So in this case, when you are using display style, you will get full sized expression the way it is represented here. If I want to get the expression it almost equal to the content what I have written in my article, then you can write here text style. It means like whatever size of text you have in your article, with the same size you are going to get this inline expression. Okay, this is mainly I am showing for the inline expression if you want to use. Sometimes in footer and header, if you want to represent anything, like sometimes it is required some type of article. So in that case also, if you have the space limit, you can use this style, different script style or script style to represent your mathematical expression. So here you just see display style, this big expression we are getting. Then text style, we are getting this expression. Just immediately write any small expression and see the variation with the help of all this command, what you are getting here. Okay? Display style, text style, then script style. Like always, we used to write the script in any variable which is coming with the help of underscore. So that variable is having size less compared to the main variable. So similarly here, by writing the script style, you are going to get the expression which is having less size compared to the your text. Okay, then script one more time you have defined like it should be less into the size, so it is going to give you this type of expression. Okay, so display style, text style, script style, and script style, four ways. In whatever you want, in which size you want, you can represent your expression in this form. So I'll show you this into the LaTeX here. Just see, this is the output. The same thing is represented, a plus b whole square equal to a square plus b square plus 2ab with the display style. Now here with the text style, and then script. So just see, we are getting the left side, and then script. So we are continuously reducing the size of the expression. So sometimes it is required in some types of articles. So if you want, you can use these four styles for your mathematical expression. So after the font size, I'll come to the mathematical symbol. The symbols for Greek and Hebrew letters we use mostly these of the symbol in mathematical expression like alpha, beta, delta, gamma, eta, okay, pi, phi, okay, mu, phi, lambda, all these symbols we are using. So for that, in overlay for LaTeX, we have the command. Yes, you see what name we used to know, the same thing you have to type. Okay, it is very easy also. You know row, how it will be represented, just type the row here. See, slash RHO. This will give you that symbol. Sigma. We know this is called sigma, and you have to write sigma only with this slash. It will give you that symbol. Tau, theta. Okay, all these things you know. The same thing you have to write. Epsilon, eta. This is gamma. This is lambda. Here, see, delta, gamma, lambda, omega, phi, pi, sigma. See, whatever you want to get, you know the name of the symbol or expression, you just type that, you will get that exactly into the mathematical environment. But you have to write all these things inside the mathematical environment with the help of dollar or with the help of equation environment, begin equation and equation. Otherwise, you may get error in that. Okay. So these are the few Greek and Hebrew letters you can use if you want. These are few mathematical construct and symbols like fraction already I have shown you. Two curly braces will come, one for the numerator, one for the denominator. This overline expression, over right arrow expression. Here see, over right arrow. Same thing is written into the command. Slash over right arrow. Okay. Over left arrow. Here over braces. Braces is there, over brace for that command is there. So whatever we want to get, SQRT already we have seen to get the square root of ABC. If you want to change this, okay, so for that one more command is there. See, SQRT, one square bracket will come. Inside that you can write anything. Q3, if you want to write 4, 5, you can change it easily. Okay, for SQRT, directly it is going to give you the by default square root. But if you want to get anything else, you can use one more square bracket here. Okay, so these are few math construct. Variable size symbols, some we have already seen. the use of summation here with the help of sum command. This also we have seen in one mathematical expression. Integration if you want to use, double integration if you want to use, just see int. Okay, with this integration oint. Okay, so whatever you want to get product, this we used to get in mathematics, whatever symbol. See, for everything there is the name, and with that we can get this symbol into the LaTeX. So these are few examples. These are not only the thing. We have many more. Few standard function names, in mathematics we used to have this cos, sine, exponent, sine, and then log, logarithmic, limit. So for that also we have all the command. Directly you cannot write only cos. It will take it as the text. If you want to get it in terms of the mathematics, you should use with slash cos, slash x, exp for x to get the exponential, slash sin h, slash arc sine. Okay, these are the things. Cot. Okay, if you want to get the limit, for that also we have the things. And here just see one of example is mentioned. Function names always should appear in Roman, not italic. The same thing I have shown you there by using the math rm command. X is rational or x is irrational. Similarly, cos is not a variable, it is the function name. Yes, it should be represented in terms of the Roman, okay, not in italic way. So see, here example is shown. If I'm using it with the command slash 10, then it is coming in this way. If I'm not using that slash, like directly in terms of the uh, content, if suppose I'm writing here, just see it is matching with what we have into the argument. Okay, so this is not the correct way to represent. If you want to use any of these things in your mathematical expression, you should type with slash. Okay, sine, cos, anything, type with slash. Then you will get the correct representation, not the italic one. This type of error we used to do usually. So always keep in mind, whatever things you want to use, always try to type with slash. Then it will come into the correct expression. Okay, so these are the few standard function names. Now binary and relational symbols. Already I have shown you a few from here, like division and times. These two I have shown you, multiplication and division. With the help of times and division we can get. If you want to get the plus minus, then P for plus, M for minus. Okay, minus plus. For equality and inequality, less than equal to, greater than equal to, we know this is called as greater than equal to, so we have slash GEQ. Here we have slash LEQ, less than equal to. Here equivalent, then EQVIV. Same thing, what we used to call, the same thing is written into the terms of command, not with the full name. Short sum in the short form, like here plus minus is written with PEM. So these are the things. If you want to anything like parallel symbol, these things can be used. Okay. Now this is the most important part of the today's presentation. Understand it clearly. All you have, I think, math type editor. Okay. So with the help of that, how you can easily write the code of your mathematical expression. Okay. Because if you have any expression in front of you, it is easier to write in terms of the mathematical notation. Like, here we have the symbols, we have the operators. But which command is being used, if you have big expression, directly typing into the LaTeX, it will take time and it will be complex also. And like, you will get more error if you are not used to it. Okay. So the solution for that is you can write equations in math type and then just copy that equation into the LaTeX, paste it, and then you will get the code, and that is being like represented into your article. So for that, math type software is required. I am showing you the way it can be done. If you have right now, you can open. If you're not having, just take this screenshot. Later on, you can follow these steps. When you will open the mat type, you will have all these options. Just click on the preferences. Okay. After clicking on the preferences, you will have the first option, cut and copy preference. Okay. Like whether you want to cut it in terms of equation only, or like for the Word file, we used to copy in the same format and we will paste in Word file, we'll get the equation. But in LaTeX, we want the code for that equation. So we have to set here which type of copy and paste or cut and paste you want. Okay. So here in the preference, you have to select the cut and copy preference. Then this you will get this dialog box. Okay. So here you have to click on the math ml or text. This is being used for the LaTeX. Okay. Whichever, if suppose you are using the software of the LaTeX, so which version you have, that you can select, or just try to select the latest one, whatever it has for the overlay, it will support always. So you have to click on the second option. Three options we have: equation object, like for the Word file it will work. Okay. So for the second, for the LaTeX, you have to click on the second option. After clicking it, click on the OK. Now your math type software is set to write the equation, and when you are going to copy that equation, and if you are pasting it into the LaTeX environment or in overlay, it is going to give you the code of that expression. Okay, so these are the steps you have to follow into the math type. I have one software, I'll show you there. Okay, example with the help of the math type. Okay, just see, I have opened this window. Here I have the option of all type of symbol. I just want to write a square. So for that, you can use this symbol. Okay, see, we have all the option here. I want to use a square. I'll click on that, a square. Like the way you are typing equation, same thing. Now, if suppose I want to use this less than equal to, okay, now I want to use p. So this expression I have written here. Now I'll just copy this. I have copied, and I'll open the overlay. Anywhere I can keep it here, suppose. Okay. I'll create here the equation environment, and without creating, let's see what is coming first. See, when I have pasted the code, so blah blah is written here. We don't have to focus on that. You can delete all those things. It is not at all required. This is not the part of code. The main thing will always come inside this square bracket. Okay, already I have started my presentation with this square bracket. So here you will get the mathematical environment. Inside that, I have written there a square less than equal to b. So see, I got this expression here, a square less than equal to b. I have written the expression here the way I want to get in my article. I have copied it, and now I have pasted in my overlay account here in this article, and I got this code. See, it is giving me this symbol I have shown you to get the power. It is giving me /LE, which is representing less than equal to. So in this way, you don't have to remember also all the commands. Okay, whatever you want to get in software, everything always will be available. See, we have the integral, every type of integral we have, every summer we have. If suppose I'll get one more sum, this type of expression, if you want to present, suppose limit is from 0 to 7. Okay, anything I want to get it here x, and I want to write here dx or anything else. So in this way, like you will get, if any bracket you want to get, you have the expression here. Okay, whatever you want to get, just type all those things. You have the matrix creation option. Also different symbols you have here, delta, epsilon, whatever you want to use. See here alpha, beta. If I'll use here alpha, okay, suppose alpha, if I'll use here alpha, beta, eta, okay, and now I'll copy this and I'll paste there what I'm getting. Okay. I'll delete these things. See, now after running I'm getting alpha, beta, eta. Okay, so I have typed there alpha, beta, the symbols, but in terms of the code I'm getting alpha, beta, and eta. Okay, what I have shown you into the PPT, alpha, beta, gamma can be represented with these symbols. So with the help of math type, you can directly get the code of your equation. If you have the large equations, complex equations, so on that case, this software will help you. The small expression can be written by your own hand. Okay, if you have understood the style, like how to give the subscript, how to write the uh, power, how to write any symbol, then it may help you. But if you want to write the complex expression, so you can use the math type option is there. If I want to create the matrix, suppose I'll take the square bracket and I can change here the row and column. Okay, 2 cross 2 matrix, have written 1, have written 2. Okay, 1 cross 2 matrix if I want to use. Here I'll paste it. We'll see. See, we got 1 cross 2 matrix. Okay, and it is giving the different command also. We have seen there with inside the matrix environment we have seen, but here with the help of different also begin array and end array, we can get this. Okay, so with the help of this, you like expression can be written in different ways. It doesn't mean like if you have learned the matrix environment with B matrix only this is going to work. No, if you have the software math type, you can type easily whatever you want. It may give you different type of command, and you may get to you may get to learn also different type of command with the help of this. So just open any article, whatever you have, whatever expression is there, try to type it in this. That way you will get to used to it. You will get to know like what symbols are available where, and then that expression just copy and paste there. Inside the equation environment also you can paste all these things. Inside the equation environment, how it is going to be done? Just type the begin equation. Okay, and the same thing I'll paste here. When you want to paste this inside the equation, at that time this square bracket is not required. Okay, you have to delete that part, only just keep the expression of your equation and you will get this with the numbering. Okay, like see, I got the 13 number for this a square less than equal to b. Okay, so in this way the use of math type is very important, and it is going to help you for any type of complex equations whatever you have. So few example I'll show you. Just try to type those things. First of all, just see the website. I have followed all these things from here. You can take the screenshot. You may get more knowledge there. And then these are the expression. First, try to type this expression y by 2 because you are aware with the fraction symbol now. This is the like basic equation here. It's the easier one. Then after that, just try to type sine x plus y. You already know how to write the sine cos. With this slash sign, you will get sine slash cos, you'll get cos. And then at the end, you just type this one. Okay, sqrt command, you know. So for the practice purpose, I kept these three. Just try to type, you are getting a not. If any doubt is there, you can ask. From my end, it is completed. If you are not able to type this, let me know. I'll show you the code.
Madam, can we start for the discussion?
Yes, sir.
Yes. Any doubt to any participants? Any doubt to any participant? You can unmute yourself and you can ask. Once one candidate asked to, can you share the PPTs? PPTs we can't share, but you can take the screenshot of the website we have used to make the PPTs, and all the details are available there. As it is a free workshop, we are not taking any registration charges, so we will not be sharing the PPTs. Can we change the numbering of the equation to A, B, C, D?
Okay. Question.
Can
As,
we change the equation number to A, B, C, D?
as of now, I didn't work like this. I don't have solution for this. I don't know. Like I have worked only with the simple numbering 1, 2, 3, 4. I'll try to find. Just mail me. If I'll get solution, I'll fill.
How to write the equation numbers on the left side, life side or left side? I think he's asking how to write the equation number on the left side.
We always used to write the right side.
Right side, yes.
When you have completed your expression, then only you can give the designation or number for that.
Means when you will use the journals package, no, it will be automatically defined
Automatically different.
where it either it will go left or right.
Hmm.
Videos will be available. Yes, videos will be available on the YouTube, same YouTube channel, and
Yes, maybe later on.
later on, so it will be available.
Last time few videos are available actually.
Last year videos are also
Ah,
there. Okay. Any other doubt to any candidate?
can we conclude, sir, now?
Yes.
No doubt.
Thank you, madam. Thank you for this wonderful talk. And
Okay.
hopefully you have all have get benefited with this, and you can use it for your writing equations in the LaTeX. And whatever things we are learning here, let's practice all this, and so that we can ask the doubts if we are having anything. So thank you, madam, for this wonderful talk. Thank you. All of you have a nice day. We will start tomorrow as per the schedule.
Okay. Thank you, sir. Thank you, supporting faculty, Vikas Vishnu, sir, and the scholars. Okay, sir. I'm ending, sir.
Okay.